Hey SM2, today, this week we'll be covering 2.4 and 2.5. So 2.4, this video is for 2.4 though. 2.4 we're going to be talking about how to solve a polynomial equation in factored form. So far in 2.1, 2.2, and 2.3 we've talked about how to add and subtract polynomials and then how to multiply polynomials together. Okay? So look here, on this side right here we have two polynomials, right? These are specifically two binomials. And last time we learned how to multiply them together. So if we multiply this using whatever method that you like, if I were to multiply these two terms together, I'm going to use the distribution method. I'm going to multiply the x by both terms of the other polynomial, so that's going to be x squared plus x, and then negative 2 times both terms over here. I'll have minus 2x minus 2. And I can multiply those together right there, so I have x squared minus x minus 2 when I multiply those together. Okay? So, if I were to graph this, this is what my function will look like right here. This is what a polynomial will look like, or this type of polynomial right here. So it looks like a U-shaped function. Okay? So what we want to know about this function is where it crosses the x-axis. Okay? This will be important whenever we keep going on with this lesson, but we want to know where this function crosses the x-axis, and you see that we cross the x-axis 2 times, right? 2 times. Okay? An important concept to know, if this is your y-axis right here, that's your y-axis. Remember that the y-axis has values of y, right? So this is y equals 1, this is y equals 2, y equals 3, y equals 4, right? This is y equals negative 1, negative 2, and so forth. Okay? So if this is y equals negative 1 right here, and this is y equals 1, well then right here, this is y equals 0. This whole line right here is y equals 0. So also notice that this is the x-axis. So the x-axis is the same thing as y equals 0. Right? The x-axis is the same thing as y equals 0. Okay, now I'll bring that up in just a second. But today what we want to learn, we're going to introduce you to what is called the zero product property. So what the zero product property says, if the product of two real numbers is 0, then at least one of the numbers is 0. So let's put that into some algebra terms. If a and b, so let's say a and b are real numbers, and a and b are being multiplied, and if a times b equals 0, then a equals 0 or b equals 0. Okay? So again, that makes sense, right? If I give you two numbers, a and b, and I tell you that if you multiply them together, your answer, the product, will be 0, well then that must mean that either your only options can be 0 times b, because that equals 0, right? Or you could have a times 0, which would equal 0, or you'd have to have 0 times 0, which would equal 0, right? So if we look at these cases right here, either a is 0, b is 0, or both are 0 in order to get the product of 0, right? So that's what the zero product property states. It says that if a and b are real numbers and you multiply them together to get 0, then either a or b or both are 0. Okay? So let's apply this with polynomials right here. So for number 4, we have a polynomial of c minus 2 and c plus 1. Note that this polynomial right here is the same thing as this polynomial up here. Okay? Same exact thing, I'm just using, this one uses x's for the variable, this one uses c for the variable. Okay? So this is a polynomial in factored form as opposed to this right here being a polynomial in standard form. So this is the same, these are the same x minus 2 and x plus 1. These are equivalent. These are the same these are the same polynomials, except they're in different forms, okay? So again, if we go back to 4, notice that this time we have an equation, not just a polynomial. We have a polynomial equation. It's an equation because right now we're setting both of these terms equal to 0. We're setting the polynomial equal to 0. So this is now an equation. So we can use the same concept. Remember, if a times b is equal to 0, then a or b or both equal 0. So in this case, we have c minus 2. So c minus 2 must equal 0, or c plus 1 equals 0. Okay? So what I did is I took the factors right here and I set them equal to 0, both of them equal to 0, because the zero product property says if you have two things being multiplied by each other and the result is 0, then one or two of those items, those terms, must be 0. So now look at this, what we have here. We have c minus 2 equal to 0 and c plus 1 equals to 0. Note that these are equations with one variable, so we can solve for the variable. Right here, I can add 2 to both sides, so then c would equal 2. And right here, I could subtract 1 to both sides, and then c would equal negative 1. So what this means is that if I were to take the value c equals negative 1 or c equals 2, if I were to plug one of these variables into my equation, it would be a true statement. So let's say I take c equals 2. So I'll put 2 in for c. Okay. 2 minus 2 right here is 0, right? And then 2 plus 1 is equal to 2. Well, 0 times by 2 is 0. So then that means we have a true statement. So if we plug 2 into our polynomial equation, we get a true statement. Therefore, this is a solution to our equation. It's the same thing for c equals negative 1. So if I put negative 1 into the equation for c, right here I'll get negative 1 and negative 2, which would be negative 3. And then over here I get negative 1 and positive 1, which would be 0. Negative 3 times by 0 is 0. So this is a true statement. So therefore, negative 1 is also a solution to our equation. Okay, so that's how you solve for polynomial equations in factored form. And what this means right here, what these two solutions mean, again, remember here, back up here, how I said that this right here, that the x-axis is the same thing as y equals 0. So if I gave you this function of y equals x minus 2 and x plus 1, but now instead I put 0 in for y, so 0 is equal to x minus 2 and x plus 1, you can see here that we're actually finding the x intercepts of this equation right here. Notice that right here, remember how we've solved down here, c is equal to negative 1, we'll look right here. That's an x-intercept at negative 1. And then c equals 2, 1, 2. This is 2 on the x-axis. So that means that whenever you set this equation equal to 0, you get values of 2 and negative 1 for x, or the x-intercepts. Okay? So that's a very important concept to know as we move forward. Anyways, let's go to number 5. So for number 5, again, we have two factors. This is a polynomial equation because it's equal to 0. So if these two factors, are being multiplied and their product is 0, then either 2b minus 6 equals 0 or 3b plus 18 equals 0. So now solve for b. So we have plus 6 and plus 6 over here. So 2b is equal to 6. Divide by 2. Divide by 2, so b is equal to 3. Subtract 18 from both sides. So that's one solution right here. Now we're going over to the next one. So if we subtract 18, we get 3b is equal to negative 18. Divide by 3, so b is equal to negative 6. Okay, so these are the two solutions to our equation, our polynomial equation. And so this is where our function will cross the x-axis. It will cross at 2 points. Okay, let's go to number 7. So number 7 says we have x minus 3 squared. Please note that x minus 3 squared is equal to x minus 3 times x minus 3. So either x minus 3 or x minus 3 is equal to 0, but these are the same thing, right? So x minus 3 equals 0 is the only answer that we can have. So we can add 3, so x will equal 3. Okay, let's go down to number 11. Okay, note that here in 10 through 11 you actually have 3 factors. This is a polynomial with 3 factors, or 3 binomials instead of 3 factors instead of 2. But we don't treat it any differently, okay? So again, we have g, we have 6 minus 3g, and 6 plus 3g. So that must mean that one of these 3, or at least one of these 3, has to equal 0, if not all of them. So take this term, set it equal to 0. Okay? So right there, we already have one solution to this equation. G is equal to 0. Okay, let's take this term right here. So we have 6 minus 3g, set it equal to 0. So we have 6 is equal to 3g, because I add the 3g. And then I divide by 3. So then g is equal to 2. So we have that one right there. Now I take 6 plus 3g, set it equal to 0, subtract 6, subtract 6, so then we get 3g is equal to negative 6, divide by 3, so g is equal to negative 2. So look, we have 3 solutions right here. So that means that this polynomial will actually cross the graph 3 times. That means it's going to look something like this. Okay, where we cross the graph at 1, or at negative 2, at 0, and at positive 2. That's the values of our solutions. Okay, let's move on. So sometimes you'll have to factor, right? So if you look down on these equations right here, these are not in factored form, right? So your goal for the homework would be to get these in factored form. Okay, so there's a method that we use called factoring polynomials using the greatest common factor. So to solve a polynomial using the zero product property, you may need to factor the polynomial, or write it as a product of other polynomials. Look for the greatest common factor of the terms of the polynomial. Okay, this is a monomial that divides evenly into each term. So the greatest common factor means this. If I give you 2 terms, let's say I gave you 15 and 10. So these are 2 numbers, right? let's list the factors of each, or the multiples. Okay, so 15 can be divided by 1, it can be divided by 3, it can be divided by 5, okay, and that's just about it. It also could be divided by itself, 15. Now let's list the factors of 10. So that would be 1, 2, 5, and 10. Okay, now let's look at what we have here. These are the factors of both of these numbers. Now let's look at what terms they have in common. So that would be the 5s and the 1s. So these are common factors between 15 and 10, 1 and 5. But the greatest common factor just means the number that is greatest of those factors. So that means 5 is actually the greatest common factor between 15 and 10. Okay? Now, let's use that idea with this example right here. Let's take the two terms, 4x to the 4th and 24x cubed. Let's list out the multiples, okay? So, we could say 2, right? So 2 can be divided, you can divide 2 by 4x to the 4th. You can also divide 4, right? And then you could have x, you could have x squared, you could have x cubed, you could have x to the 4th. So these are all the terms that you could divide evenly by 4x to the 4th. Okay? So again, divides evenly into each term. So let's take 24x cubed now. Now let's list the factors of 24. So that would be 1, that would also be 1 over here. So 1 and 2, 4, 6, 8, 12, 24, and then we'd have x, x squared, and x cubed. Now let's take a look at the list of these factors for both terms and see what they have in common. So first of all, I see that this one's the greatest common factor right here, x cubed. Both of these terms have an x cubed. And then now let's look at the numbers right here. This is 4 right here. This also contains a 4. So that means that 4x cubed is the greatest common factor for these two terms. Okay? So whenever we factor, we take a 4x cubed away from both terms. Okay? So again, it needs to divide evenly into each term. So if I have 4x to the 4th, and I take away a 4, and I take away an x cubed, then I'm just going to be left with x. So I'm going to write that here. So I'm going to write my greatest common factor, and then in parentheses, I'm going to write down x, because that's what's left over from the first term. Okay, now let's look at the second term. So if I have 24x cubed, and I want to take away a 4x cubed, or divide this by 4x cubed, if I divide this by 4x cubed, well, 24 divided by 4 would be 6, and x cubed divided by x cubed would be 1. So then I just have 6. So then I say plus 6. So now I've completed the process of taking a polynomial that's in standard form, and now I have the same polynomial in factored form. So now, since I have it in factored form, that means I can solve this polynomial. Now let's go to some exercises down here. So for 19, I have two terms. I have 6k squared, and I have k. So if I list the multiples of these, well, let's list the multiples of 6 first. That'd be 1, 2, 3, 6, and then multiples of k squared would be k and k squared. Now k can only be 1 and k. So let's look at what they have in common, and that pretty much is only this k right here. These are that's the greatest common factor. So what I do is I take the k that's in common, and then in parentheses I write what remains. So if I take the first term, 6k squared, if I divide that by k, then that means I'm going to be left with 1k on top. So this will be 6k. And then if I take the second term, k, and I divide that by k, well, that's going to equal 1, so then plus 1. So that would be the answer right there. Well, that's how you factor anyways. But remember that this is equal to 0. So if it's equal to 0, then I have to take both terms and use the zero product property and set both terms equal to 0. So k equals 0 and 6k plus 1 equals 0. Then I solve, so I subtract 1. So 6k is equal to negative 1. Divide by 6, divide by 6. So then k would equal negative 1 over 6 as well as 0. Okay? Now let's go over 20 now. So we have the term 35n, okay? And then we have the term 49n squared. So if we list factors of each, 35 can be divided by 1, that can be divided by 5, that can be divided by 7, okay? And then n, it can be divided by n. 4n squared could be 1, 7, that's pretty much it, and then n and n squared. So if we look at what they have in common, they both have a 7 and an n, so I can factor those out. So let's take the 7n, okay, now I have 35n. If I divide that by 7n, the n's would go away. 35 divided by 7 is 5. So then in the parentheses, I'd be left with 5 minus, now let's take the 49n squared and divide this by 7n. 49 divided by 7 is 7. N squared divided by n is n. So then this would be 7n equals 0. So 7n equals 0, divided by 7, divide by 7, so n is equal to 0. And then I have 5 minus 7n equal to 0, so plus 7n. So 5 is equal to 7n, divide by 7, divide by 7, so n is equal to 5 over 7. So that would be the solution to our equation. Also note this, guys. Let's take this equation again that we have here. So if this is 7n times by 5 minus 7n, let's multiply these two monomials together, these two polynomials together. So let's distribute that 7n inside. Well, 7 times by 5 is 35n. Minus 7 times by 7 is 49. N times by n is n squared. So you see here how we have the same thing as we had before. That's because factoring undoes multiplication. Factoring undoes multiplication of polynomials. Okay, let's do one more. Let's go to number 23. So for 23, we have 22s equals 11s squared. What I'm going to do is I'm going to subtract this 22s from both sides. So now I have 11s squared from over here minus 22s, and now that's going to be 0, so equals 0. So now we have an equation that's equal to 0. And now I'm going to factor. So if I look at these two terms, I notice that there's an 11 and an s for both of them. So if I divide both of these by 11 and s, that's going to be my greatest common factor, 11s. So if I take 11s squared and I divide that by 11s, I'll just be left with s. And then if I take 22s and divide that by 11s, then I'm going to be left with 2 equal to 0. So again, if I want to check my work, I can distribute that, and then I'd get 11s squared minus 22s. And that's the same thing as we had before, so therefore I did factor correctly. So now I have two terms, and they're equal to 0, so use the zero product property. So I have 11s, and that equals 0. Divide by 11, s is equal to 0. Now I take the other factor, s minus 2, set it equal to 0, add 2, s is equal to 2. So right there, I have two solutions to my equation, and thus it is solved. Okay, so that should cover everything that you need to know for your homework for 2.4. Let me know if you have any questions. Come to class during my consultation hours, and I'd be happy to help you guys. Thanks, guys.